All right, let's just jump right into this explainer by tackling a massive misconception head-on. A coding agent is not just a smarter chatbot. I know it's super tempting to think that underneath a tool like Claude is this giant, omniscient brain just effortlessly spitting out perfect software. But as we explore the architecture outlined by developer Srijit Srijayan, you're going to see that the model itself is actually just one piece of a much larger and far more intricate machine.
So, the absolutely crucial point here is this. The magic of Claude Code is not the model alone. It is the agentic harness. Without this harness, a language model is, well, ultimately just a text generator. It can talk a big game about code, sure, but it can't actually do anything. It's the harness that completely transforms it from a smooth conversationalist into a highly capable, autonomous software engineer.
Think about it like this. On one side, we have the bare model, right? It just talks. On the other side, we have the agentic harness. You can picture this harness as an invisible control plane wrapped entirely around the model. It's what actually hands the model the tools to read your files, gives it an environment to run code, provides the memory to remember what it just did, and gives it a checklist to keep it from getting completely distracted. Today, we're going to crack open this black box and deconstruct the harness layer by layer, starting with the very engine that drives the whole operation.
So what's driving this? Well, every coding agent has a beating heart. And in the software engineering world, we call this the agent loop. It is the fundamental cycle that turns all that talking into actual tangible doing. It's honestly almost embarrassingly simple in concept, but it is the absolute foundation of everything a coding agent can achieve. Let's break down exactly how it flows.
Everything kicks off with a user request. That's just you asking the agent to say, refactor a login system. The model reads that message and immediately has to make a critical decision. Does it need to use a tool to accomplish this, or can it just answer right away? If it decides to act, it calls a tool. The system runs it and then feeds the result right back into the model. And then, the cycle just repeats. The loop literally only breaks when the model decides the job is completely done and replies to you with plain text. To really lock this idea in, think of it exactly like hiring a contractor who has a clipboard and a checklist. They look at what needs to be done next, they go do it, they check the result of their own work, and then they decide on the very next step based on that result. They definitely don't come back to talk to you until the entire list is finished. Whether a task takes one single step or 50 steps, the loop scales naturally to fit the job. It's elegant, and actually, modern frameworks like LangChain's deep agents give you this loop right out of the box.
Okay, so the loop is our engine. But an engine is totally useless if it can't interact with the road, right? If the loop is the engine of our agent, then the tools are the hands. A model with no tools can only hypothesize. But a model with carefully crafted tools, it can actively read your codebase, safely change it, and even test its own work.
Out in the wild, real coding tools generally fall into 4 dedicated families. You've got reading tools to scope things out, like using glob to find files by name or grep to search inside them. Then you have editing tools to actually safely write or modify those files. There's the execute tool, which acts pretty much just like your terminal. And finally, the delegate tool. This one is fascinating. It allows the agent to actually hand off a subtask to a helper. These are the standard out-of-the-box hands you'll find in frameworks like LangChain's deep agents.
Now, a massive question you might be asking yourself right now is why not just let the agent use raw shell commands for everything? Why go through the trouble to build dedicated tools at all? Well, it essentially comes down to 2 things: token budgeting and clean permissions. You see, a dedicated read tool can measure a file and strategically trim it so it doesn't overwhelm the agent's memory. A raw shell command like cat, that might just dump a massive file and completely flood the context window. Plus, a dedicated edit tool tells the harness exactly what is happening, which allows it to apply safety rules. A raw shell command is honestly just a dangerous, unpredictable black box that can totally derail your agent.
All right, we have the hands. Now we need to give this agent a brain. If you drop a complex request on a bare model, it tends to just flail around and go in circles. To solve this, the harness introduces something called planning. Before touching a single line of code, the agent writes a structured to-do list. Just like a good cook reads the entire recipe before they even think about turning on the stove, the agent plans its steps. And here is the absolute genius part of this system. During a really long task, the harness quietly re-injects this to-do list back into the conversation. It acts like a super helpful colleague, just sliding the checklist back in front of the agent, ensuring it never loses track of the original goal amidst all that tool output.
But look, even the best brain fails if it keeps forgetting what it's actually doing. So now, we're tackling what is arguably the hardest engineering problem in all of AI, running out of memory.
You see, every single language model has what's called a context window. This is a hard, physical limit on its short-term memory. Read a few massive code files, run some dense terminal commands, and boom, this window fills up incredibly fast. When it overflows, the agent completely forgets your original instructions, and your whole project just goes right off the rails. To beat this, the harness literally offloads data. It uses files as external memory, so the agent only has to remember a file name, not the entire contents of the file. The harness will also automatically pause the loop to summarize and compact older conversations, keeping the active memory completely clean.
But what if the task is just fundamentally massive, like searching an entire enterprise codebase? That is too big for one memory window. And this is where delegation absolutely shines. For those massive tasks, the main agent actually spins up a specialized subagent in a totally separate loop to do the heavy lifting. Think of it exactly like a manager. The manager delegates a huge research project to a junior employee. The junior employee wades through 50 documents, does the grunt work, and comes back to the manager with a clean one-paragraph summary. Because of this, the main agent's desk stays totally clean, and you completely bypass the memory limit.
Now, pause for a second, because there is an absolutely critical safety rule here that we have to understand. Subagents are strictly forbidden from spawning their own subagents. This strict depth limit is absolutely essential. Imagine if a confused subagent was allowed to create another subagent, which then created another. You would instantly trigger an infinite loop of nested helpers. It would just become this runaway process that burns right through your entire API budget in a matter of minutes. Thankfully, the harness specifically prevents this.
Okay, so we've built an engine, we gave it hands, a brain, and external memory. But before we let this autonomous software engineer loose on our computer, we desperately need some brakes. We are now arriving at the single most important safety idea in this entire system.
This means the permission layer has to sit completely outside the AI model. When the agent decides it wants to edit a file or run a shell command, that action does not go straight to your machine. Not at all. It gets intercepted. It absolutely must pass through the permissions and OS-level sandbox layer first. The system will literally pause and wait for explicit approval before executing any risky operations. This is a huge trap that so many beginners fall into. You cannot, I repeat, cannot keep an AI agent safe just by typing "please don't delete anything important" in its system prompt. That is not security. That is literally just a sticky note. The model can ignore it, it can misread it, or it can even be talked out of it by bad code. Real, actual safety lives in the harness. It lives in an OS-level sandbox that can flat-out block dangerous tool calls no matter what the model actually wants to do.
All right, we've essentially torn down the engine, the hands, the memory, and the brakes. We've seen exactly what the harness is made of. So let's put it all back together. How hard is it to actually build this thing yourself?
100. That is literally the exact number of lines of code it takes to build this entire agentic architecture today. The loop, the custom tools, the planning, memory management, a subagent, shell access, and persistence. All of it in about 100 lines using a modern framework like LangChain's Deep Agents library. Just a few years ago, this would have been a massive, complex engineering undertaking. Today, the core harness structure is practically just a library call.
But let's be totally real about the engineering side of this for a second. The framework gives you the loop and the memory for free. That's the easy 80%. But you still have to put in the hard 20%. You have to iteratively tune the system prompt so the agent actually knows when to use which tool. You have to meticulously set up that OS-level sandbox isolation because safe shell execution is completely non-negotiable. And you have to write highly reliable tools. Remember, an agent is only ever as good as the tools you hand it. If your custom test runner is flaky, well, your autonomous agent is going to be incredibly flaky too.
So, the black box is officially open. We've seen that the real magic isn't just the AI itself, it's the harness that empowers it to act, to plan, and to remember. You now know exactly how tools like Claude Code tick under the hood, and you understand the architecture that separates a simple, talkative chatbot from a highly capable engineering agent. The framework gives you the power, but you've got to build the discipline. So I'll leave you with this. The question isn't just whether you are ready to build your own autonomous developer, it's what are you going to command it to build first.